Welcome to today's lesson. In today's lesson, we're going to be looking at indices and logarithms. And one thing that I want you to understand from today is indices is the same as logarithms. So if someone asks you to find the logarithm of a particular number, in other words, what they're asking you to find is the index or the index, or like to what power are you supposed to raise a particular number to get this right. So here on the screen you have log 1000, which is equal to 3. And what does it mean? In other words, what you're saying is when you have a number that is like these logs, they are in base 10, right? So what you're being asked is to what power are you supposed to raise 10 so that you get 1000. So the right way to calculate that would be this. Let's say you have this. So you're saying log b to the base of a is equal to x. So in other words, what we are saying is to what power are you supposed to raise a to get b. So the next stage from here would be b is equal to, and you take this one as your base and it raises x like that. So you're going to have b is equal to a to the power x. So here if we calculate this one, you say log to the base of 10 of 1000, and we say is equal to x. The next stage here would be 1000 is equal to 10 raised to the power x, and 1000 is equal to 10 to the power 3, which is equal to 10 to the power x. Since the bases are the same, we are saying 3 will be equal to x. So that's the same concept that we are applying on all these numbers, and that's how we are getting these values. So you're going to just go through all of them. We say log to the base of 10. I say if it's not specified, the assumption is it is to base 10. Okay, so we are saying log 100 is equal to x like this, and you say 100 is equal to that base raised to the power x, and this is 10 to the power 2, which gives us 10 to the power x. Since the bases are the same, we are saying 2 is equal to x. We go further, we say log to the base of 10 is equal to x, and we say this 10 is equal to the base of 10 raised to the power x, and if it's not specified here, we know it's raised to the power 1, and 1 is equal to x, which means we are saying the power is equal to 1. So if you raise 10 to the power 1, you get 10. If you raise 10 to the power 2, you get 100. If you raise 10 to the power 3, you get 1000. Okay, we move further. Log to the base of 10 of 0, 1 is equal to x, and we say 0, 1 is equal to 10 to the power x, and this is equal to 1 over 10, which is equal to 10 to the power x, and this is equal to the reciprocal of that number, which means if you invert it like this, you end up with 10 to the power minus 1. So this is coming from the concept where we said a to the power minus x is equal to 1 over a to the power x. So it's like we are working in the reverse, coming back. So that's how we get minus 1 being equal to x. And if you go to this question, or to that number, you realize it's saying log to the base of 10 of 0, 1 is equal to minus 1. So this is the working here. This is the working that I have shown here. How do you get that minus 1? You get that minus 1 this way. So we move further to calculate how they got the other answers there. So to the power is equal to x. So we're saying 0,01 is equal to 10 to the power x, and this is 1 over 100, which is equal to 10 to the power x. This is equal to 1 over 10 to the power 2, which is equal to 10 to the power x, and the reciprocal is equal to 10 to the power minus 2, which is equal to 10 to the power x, and minus 2 will be equal to x, like that. And the last one, which says log to the base of 10 of log to the base of 10 of 0, 0,001 is equal to x. So we are saying 0,001 is equal to 10 to the power x. So this number of decimal places, they tell you like how many zeros are going to be in front of 1 on the denominator, and it's equal to 3. And here you're saying 1 over 10 to the power 3 is equal to 10 to the power x, and the reciprocal is 10 to the power minus 3 equal to 10 to the power x, and minus 3 will be equal to x, and minus 3 will be equal to x. So this is proof to all the answers that we got here above. So we had this here. So all the examples that I was calculating, I was just trying to prove like where did you get these answers, where did you get these logarithms, where did you get these powers, because we said logarithm means the same as power, it means the same as index. So we are being asked, to what power are you supposed to raise this base to get this particular number? To what power are you supposed to raise 10 to get 0,001? So this is proof of how you get to that particular answer. So thank you so much for watching. I will see you in the next lesson.